Now that we've had some time to work with rational functions and sketching the various parts of rational functions, we're now going to move into actually simplifying expressions. And fortunately, we've had a little bit of experience with this, dealing with the functions. Now, we're going to layer in some other parts to the simplification process, such as multiplying and dividing the different rational expressions. So let's just take a quick look here and review a little bit the rational functions, the rational expressions. If we want to simplify a rational expression, basically we want to cancel out any common factors that are in the numerator and the denominator. So we first of all have to be able to factor everything comfortably before we thus eliminate or divide out any of those common factors. And so you can see here in this first example, we have a common x value that can be factored out of both parts. And then of course, that can simply be marked out or canceled out or divided out, however you want to look at it. So x over x equals to 1, and then we no longer have that. If you look at example number 1, we have a little bit more complex view of some polynomials in each numerator and denominator, and so a little bit more factoring involved. But again, still the same deal. We cancel out the common parts, leaving us with just the simplified version. Now, one of the things that you're going to see in this particular unit is a term called the excluded value. Keep in mind the excluded value is just a fancy term for the number that makes the rational expression undefined. So we've already been doing that on a regular basis whenever we were finding vertical asymptotes and holes in rational functions. Those values that made the function undefined are just now going to be termed their excluded values. So nothing more than that should be a very comfortable transition for you. So let's take a look at a couple problems here. Sample problem number 1, if you go ahead and work on that, and then we'll come back and take a look at the solution. Okay, so first thing we need to do is we need to actually factor both the numerator and the denominator. Now that I've factored both the numerator and the denominator, I can cancel out the common parts, leaving me with simply x minus 6 over x minus 1 as the simplified expression. Now, part B asks us to find the excluded values. Now, keep in mind that the excluded value goes back to the original, not the simplified version. Okay, so basically we need all of the values that make this rational expression undefined. The way that you can do that is just set that equal to 0. Now, most of you should probably be able to just quickly figure this out in your head, but if you needed to actually do this mathematically, you could just set the denominator equal to 0 and then solve for x. And we get plus or minus 1 as the excluded values. Notice that if we would have only done it on the simplified version, we would have missed one of the excluded values. Alright, so that's a quick introduction to simplifying rational expressions. Now we'll take a look at simplifying expressions, rational expressions that involve multiplication and or division. So keep in mind that the same rules still apply. We need to find all the common factors in the numerator and denominator. Now, simply enough, you can do this in separate steps if you want. You could either first multiply the two numerators and the two denominators together, and then after multiplying the numerators and the denominators together, then factor out or cancel out the common parts. Or you could choose to actually do some of the canceling out first and then take the leftovers and multiply them together. The problem with this second method is you may end up having a second level of clearing out some of the multiplied parts together, but it's going to change or be different from problem to problem, so you'll have to use your experience with that. Now, some of these problems that we're dealing with now are similar to the exponent properties that we used back in previous units. So that you can see here in example number 2, we have multiple variables, and we're going to use our exponent properties to multiply them together. So you can see in the solution to example number 2, we elected to multiply the numerator and denominator first, and then apply the exponent properties through the division, thus leaving us with the simplified version. So this type of problem should look very familiar to you. Now, you have 3 examples to work: sample problem number 2, sample problem number 3, and sample problem number 4. So go ahead and work those 3 sample problems and then come back and take a look at the solutions. So if we look at this problem, what I went ahead and did was go ahead and multiply the numerators and the denominators together first. Then, if you remember, when we did exponent properties, we suggested that taking each of these parts, the numerical parts, the x values and the y values, and doing them separately may be the best way to go about doing this. And so that's what I went ahead and did. So we have 5/3, x to the third, y to the third. For sample problem 3, what I elected to do before multiplying everything together was to actually factor the 2 parts. And the reason I did that is because if I would have multiplied everything together initially, I would have gotten some very big, ugly polynomials that would have been really, really challenging to factor on the back end. Now, keep in mind that whenever you are multiplying, technically everything on the numerators together, everything in the denominators together. And so technically anything that's on top and bottom can be canceled out. So I can go ahead and start canceling out right off the bat here, 4x and 4x. And then I also have x plus 3 and x plus 3. Now I'll go ahead and stop right there and just rewrite what I have left over. Okay, now I've gone ahead and rewritten the given material so that we can see what's left over here. Now we have this term 1 minus x. We have x minus 1 in the denominator, and they look like they have something in common, but they're not exactly the same term. So what you can do is you can see here that you could actually rewrite this first term in an order that looks familiar. And you can clearly see that the negative x plus 1 is not the same as x minus 1. However, you can actually factor out a common negative 1 from that first term. And so if we do that, what we end up getting is an x minus 1 left over. And so now we have a situation where we can cancel out the x minus 1s. Now I'm going to go ahead and choose to redistribute this negative 1 back over here to this x minus 2. So my final answer, simplified, is negative x plus 2. Alright, so let's take a look at the next sample problem. Now this one can be a little bit tricky if you're not paying attention. But keep in mind that this second term is really all over 1. Now, here's where you have to reach back a little bit to your polynomial functions. 4x squared plus 2x plus 1 actually cannot be factored, and so you have to be real careful about trying to factor that up front. But I'm going to go ahead and multiply together, or at least put together the numerator. Now, if we look at 8x to the third minus 1, that is a sum or difference of cubes in this case. And so we can actually factor the difference of cubes. And so if you remember the SOAP acronym for same, opposite, always positive, that tells us what our signs are going to be in this factor. And if you notice here, we actually ended up having a quadratic that is the same, that can cancel out. And we get our simplified value. The last kind of problem that we need to look at is a division problem with rational expressions. And if you remember back from elementary, possibly middle school, the way that we divided fractions is that we switched the operation from division to multiplication, and we flipped the second fraction. And so then what we ended up doing is, instead of having a division problem, we've just created a multiplication problem for the rational expression. And so basically the same properties are going to apply here, since a rational expression is in a fractional form, just with a lot more complex polynomials going on. So you can see in example number 3, we've just kind of given you a nice little visual example. First things first, we flip the second expression and make it multiplication. Then we elect to go ahead and factor everything out right off the bat. Upon doing that, we're able to cancel out all the terms that are both in the numerator and the denominator from either one of the fractions, and then finish the problem with what's left over. Now, it's not required of you to put that material back together. There's no need to re-multiply all of that. Now, in this particular case, the example problem listed any possible excluded values. Notice that the excluded values apply to everything in the original expression. So just need to be very careful not to only go to the simplified version. So go ahead and give a try at sample problem number 5 and then come back and watch the solution. And you can see here in our first step, we've changed this from division to multiplication. Now, my recommendation at this point is to go ahead and factor everything right off the bat. Now that I have all the factors, then I'm just going to go ahead and start the canceling out process a little bit at a time. Obvious ones are x minus 4 and x minus 4, x minus 2 and x minus 2. One of the things that you got to remember is that the 5x, that's technically multiplication going on there, so that's 5 times x. So they're actually separate entities of each other, so this x and this x will also cancel out, thus leaving us with 5/3 as the simplified expression. All right, that's a good example of dividing rational expressions. This was a short, pretty sweet little lesson, something that you're probably familiar with in Algebra 1. So you can now move on and work your Math Excel problems.